Chapter 4: Normal Distribution. Objectives of Chapter 4. By the end of this chapter, students should be able to understand the concept of normal distribution, understand the relationship between probability and area, apply the probability theory in industrial cases. The keywords in this chapter are mean, standard deviation, normal distribution, and probability. Introduction. Normal distribution is often referred to as the Gaussian distribution. The distribution curve is governed by the exponential formula shown here. You do not need to memorize this formula, nor use it to do calculations, because the values needed can be obtained from page 6 of your standard handbook. However, what you need to know about normal distribution is that it is a continuous probability distribution. If you turn to page 6 of the standard handbook, you can see this bell-shaped curve at the top right-hand corner, and that is the typical shape of the curve for normal distribution. Recall Chapter 3, where you learned about frequency distribution. Here are two histograms, one using a sample size of 32 and the other has a sample size of 55. The frequency polygons are also shown. As the sample size increases, the frequency polygon starts to smoothen out and approach to become what is known as a normal distribution curve. The normal distribution curve follows the Gaussian distribution equation. It is symmetrical about the mean. In a normal distribution, standard deviation is a key value. It is denoted by the Greek letter sigma. Sigma describes the spread of data in the distribution, that is, how widely or narrowly are the data points spread above the mean. The formula used to calculate sigma is shown. It is the square root of the average of the sum of differences between each data point to the mean. The narrower the spread of data about the mean, the smaller is the value of sigma and vice versa. Now compare the two curves that are shown. You will observe that plus minus 3 sigma always extends to almost the entire width of each curve, regardless of how wide or narrow the curve is.